Good morning, student. Myself, Professor Dilip. I am from the Electrical Engineering Department. Today I will teach you the AC bridge. AC bridge. Okay. AC bridge is nothing but the modification of Wheatstone bridge. That means it is nothing but the modification of DC bridge. It is the modification of DC bridge. Okay. Now you see, it is bridge. I am telling that this is bridge. It is not civil bridge, it is electrical bridge. So it consists of 4 arms and 4 nodes. Okay. Now you see, this is modification of DC bridge. So obviously there is a difference between AC bridge and DC bridge. Now what is the difference between AC bridge and DC bridge? Just I am giving small idea. DC bridge, AC bridge. Okay. You see, according to name is supply. Supply is DC. Here, supply AC. Good. And it measured only resistance because it has no frequency. But from here we can measure inductance, capacitance, resistance, and subsequently you can measure power factor, loss, etc. Number 3. Here it cannot represent by any phasor. Cannot represent any phasor, but it can be represent phasor diagram. Okay, so I am just giving the idea about the AC bridge and DC bridge and what is the difference between AC bridge and DC bridge. Now we'll give the balance condition of AC bridge. Balance condition of AC bridge. What is written here? Balance condition. For balance condition, what we have to do? That we have the idea from the class 12 level also. For balancing the bridge, we have to give in the supply opposite to pair end, and we have to measure the condition. That means detect. Okay. Now, already I told you that the 4-arm bridge. So we draw the 4-arm bridge. Here you see difference between the DC bridge and AC bridge is that 4-arm consists of impedance instead of resistance. This is the 4R bridge. So I am drawing that. This is the all are the impedance. Z1, Z2, Z3, and this is the fourth term, Z4. Okay. What I told you that we have to supply the energy, that is equal to here AC source. This is the symbol of AC. E that equal to E0 sine omega t. Okay, this is the 4R. A, B, C, T. For balance condition, we have to another thing to detect the balance. Here we have given detector. It's the D. This is the detector. For DC bridge, simply we have taken the detector is a galvanometer, but here detector is the three types. This is the detector. Here this detector are you can use vibration galvanometer, you can use headphone, you can use tunable amplifier. Okay. Now we are given the supply. So the current will flow through this. Suppose the branch current, this is I1, this is I2. What is the balance condition? Balance condition means no current flow through the detector. That means the current flowing through this is 0. Okay. So the potential drop across this arm will be same. Potential at point B and D will be same. That means VB equal to VD. Okay. That means drop, if we consider drop across this is E1. Here across this we are considering in general. Suppose this is the second arm, E2. Across this is E3. Across this is E4. Now, no current is flowing through the detector. That means the potential at terminal B and D are same. This is the condition for the balance of the bridge. Now, if we take this way, minus VB equal to minus VD. So we can write VA simple. VA minus VB equal to VA minus VD. So we can say that simply by mathematically the potential across these arm equal to this arm. Now current flowing through this arm is I1 and impedance is Z1. That means potential drops, we can say I1 Z1 equal to I2 Z2. This is equation 1. Okay. Similarly, from this again we can write VB, simply we are considering that is one VC minus VB equal to VC minus VD. Okay, we can take this one. That means the potential across these and these will be same. That means the same current is flowing through this I1 and this is also I2. So I1 Z3 equal to I2 Z4. This is equation 2. Okay. So if we divide 1 divided by 2, so what we are getting? I1 Z1 by I1 Z3 equal to I2 Z2 by I2 Z4. This was a cancel. So we can say I1 Z1 Z4 equal to Z2 Z3. So this is the balance condition. That means this is the balance condition. Now, what is Z? Z equal to impedance of the corresponding branch. So Z, it has two parts, one the real part and the imaginary part. You can simply write it is R plus Jx. This R is nothing but the resistance and this is the reactance part. You know that Z can be represented to another way also. Mod of this and angle. So these four arms you can represent Z1 equal to mod of Z1 at an angle theta 1 or R1 plus Jx1. Z2 is the impedance of the second arm, mod of Z2 angle theta 2 or R2 plus Jx2. Z3 mod of Z3 angle theta 3 or R3 plus Jx3. Z4 mod of Z4 at an angle theta 4 or R4 plus Jx4. This is the impedance of the four arms. Now we got this equation. If we substitute this Z1 Z4 equal to Z2 Z3. So we can write here mod of Z1 at an angle theta 1 mod of Z4 at an angle theta 4 equal to mod of Z2 at an angle theta 2 mod of Z3 at an angle theta 3. So you can write Z1 mod into mod of Z4 at an angle theta 1 plus theta 4 equal to mod of Z2 at an angle, sorry, into mod of Z3 at an angle theta 2 plus theta 3. That means another condition we are getting Z1 product of the mod of Z4 equal to product of the Z2 the product of the Z3, this one, and at an angle theta 1 plus theta 4 equal to theta 2 plus theta 3. Okay. Now another form we got in terms of resistance and reactance. If we put this one, then Z1 can be represented by R1 plus JX1. R4 can be represented as R4 plus JX4. And Z2 can be represented as R2 plus JX2. And Z3 can be represented as R3 plus JX3. Okay. So simply we are multiplying this. If we multiply this R1 R4, it will be R1 R4. And X1 X4 if we multiply J and J, so it will be minus X1 X4 plus, if we take the common J, then J this multiply this one, so R4 X1 plus this one R1 X4 equal to, similarly this one R2 R3 minus X2 X3 plus J X2 R3 plus R2 X3. Now separating the real part and imaginary part. Okay, separating the real part and imaginary part. What are you getting? Getting that R1 R4 minus X1 X4 equal to R2 R3 minus X2 X3. One condition. And imaginary part R1 R X4 plus R4 X1 equal to R2 X3 plus R3 X2. So this is the another condition. So this is the condition for the AC balance the bridge. Okay, next day we will continue the measurement of inductance, capacitance and other parameters.